In this lesson, we will solve the equation x squared minus x cubed equals 36. We will find all values of x that make the statement true step by step. Step 1. Move all terms to one side, so the equation equals 0. It is convenient to have a positive cube term. Add x cubed to both sides, and subtract x squared from both sides. Now we have x cubed minus x squared plus 36 equals 0. Step 2. Try small integer values to guess a root. We test values like -3, -2, -1, 1, 2, and 3. We will evaluate f of x equals x cubed minus x squared plus 36 at these values. Notice that when x equals -3, the value is 0. So x equals -3 is a root, and x plus 3 is a factor. Step 3. Divide by x plus 3 to factor the cubic. The quotient is x squared minus 4x plus 12. So the factorization is left parenthesis x plus 3 right parenthesis times left parenthesis x squared minus 4x plus 12 right parenthesis equals 0. Step 4. Solve the quadratic factor x squared minus 4x plus 12 equals 0. We use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a, with it equals 1, b equals -4, and c equals 12. The discriminant is 16 minus 48, which is -32. So the roots are complex. We simplify the square root of -32 as 4i times the square root of 2. That gives x equals 2 plus 2i square root 2, and x equals 2 minus 2i square root 2. So the full solution set is 3 values. One real root at x equals -3, and 2 complex conjugate roots at x equals 2 plus 2i square root 2, and x equals 2 minus 2i square root 2. Let us visualize the cubic function, y equals x cubed minus x squared plus 36. We draw coordinate axes and plot the curve. The graph crosses the x-axis only at x equals -3, confirming our single real solution. Finally, to acknowledge the complex solutions, we show a simple complex plane. The points at 2 plus 2i square root 2 and 2 minus 2i square root 2 appear as symmetric points above and below the real axis. Summary. We moved all terms to get a cubic equal to 0. We found a real root at x equals -3 by testing small integers. We factored using x plus 3, leaving a quadratic, and solved it with the quadratic formula to obtain 2 complex conjugate roots. Therefore, the solutions are x equals -3, and x equals 2 plus 2i square root 2, and x equals 2 minus 2i square root 2.